Hi everyone! Over the next 5 minutes, I'm going to be walking you through a few demos of my embedded systems project. I built a breathalyzer / ignition interlock system using NXP's LPC802 development board with the context of combating drunk driving. Now, my circuit is already built for the most part, but I do need to finalize some components, so without further ado, I'm going to get to work. It is way too beautiful today to be stuck inside in quarantine, so I figured I'll make myself a coffee and let's get some soldering done. We're going to start by powering the prototype with a portable charger and adjusting the contrast of the LCD screen with the potentiometer in the back. The system begins in an off state, as indicated by the LEDs. The sensor is located at the top of this model, so that's where I'll be blowing into. By pressing the button at the front, I trigger a GPIO interrupt and begin blowing into the sensor for approximately 8 seconds. The device reports my blood alcohol content level, and since it's at 0, it's safe for me to drive. The headlights turn on using pulse width modulation with an 80% duty factor. The system remains in a steady state until I reach my destination, and I can then turn off the car via GPIO interrupt. Next, I'm going to demonstrate that the breathalyzer is making accurate measurements. In the spirit of COVID-19 quarantine, I decided to calibrate the system using hand sanitizer with a 68% ethanol content. With our air-to-blood concentration conversion factor of 0.21, our expected BAC reading should be roughly 0.14%. Instead of blowing into it, this time I will dip the Q-tip into the sanitizer and hover it over the sensor. Since the BAC reading is higher than the legal limit of 0.08, on the next button press, the driver will be prompted to blow again for a maximum of 3 attempts. Throughout these attempts, the LPC802's SysTick timer is updating the rolling average buffer with new sensor outputs every 2 seconds. The buffer stores the 10 most recent ADC values in a first-in, first-out manner, and a new average is calculated with each interrupt. If by the end of the 3 attempts the BAC is still too high, the device will encourage the driver to call an Uber and the headlights will remain off. And now it's time for the real meat of this demo, testing the device with human alcohol consumption. I used an online calculator to determine my expected BAC level after taking 1 shot of liquor and waiting 1 hour. This would probably be a good time to mention that the BAC limits used for this device are strictly for demo purposes. There is a zero tolerance policy for drivers under the age of 22 that is not covered in the scope of this project, so just because I get a reading less than 0.08 does not mean that I should be getting behind the wheel. Now hopefully in an hour when I test my device, we'll see a BAC reading of 0.03%. But first, drinks.
One hour later.
Once again, I'm going to blow into the sensor after pressing the button to indicate that I want to turn on the car. As you can see, the device is measuring and reporting my BAC level as expected, and the car is turning on successfully, which concludes the demo of this ignition interlock system. Thanks for watching.